Happy learning! Today we're going to talk about linear functions. So what exactly is a linear function? A linear function is a function of the form y equals mx plus b. Okay? X is our variable, y is a variable, m and b are constants. Okay, so for example, maybe we have something like y equals 3x plus 5. Here m would be 3 and b would be 5. This is an example of a linear function. The graph of a linear function, you're never going to believe this, is a line. But so why is that important? It only takes 2 points to determine a line. So only 2 points are needed. Only 2 points are needed to determine its graph. Right? Once we find the 2 points, we connect the dots and we extend infinitely in both directions. So suppose we had our graph. This point where the line crosses the x-axis, this is called the x-intercept. And this point where our graph crosses the y-axis is called the y-intercept. Okay, so if we could find the x-intercept and y-intercept, that's 2 points, and we could connect the dots and we'll know what the graph of our line looks like. So to find the y-intercept, or to find either of the intercepts, so let's start with the y-intercept. So to find the y-intercept, this is when our x value is 0. So we're going to set x equal to 0 and solve for y. And then similarly, to find the x-intercept, we're going to set y equal to 0 and solve for x. All right, so let's do an example. Let's find the intercepts and then graph. All right, and our equation is 3x plus y equals 9. All right, so this is not written in y equals mx plus b form. But if we subtracted the 3x over, it would be y equals negative 3x plus 9. So it's very clearly a linear function. All right, so let's start with the y-intercept. I wrote that first. All right, so to get the y-intercept, we set x equal to 0 and solve for y. So it's 3 times 0 plus y equals 9. 3 times 0 is just 0, so this is y equals 9. This by itself is not the y-intercept. The y-intercept is a point, so it has an x component and a y component. The x component is 0, the y component here is 9. All right, to get the x-intercept, set y equal to 0 and solve for x. All right, so we have 3x plus 0, so 3x equals 9. Dividing both sides by 3, we get x equals 3. All right, and again, the x-intercept is a point. So it has an x component and a y component. The x component is 3, the y component is 0. And now that we have these 2 points, let's plot them, connect the dots. All right, so maybe up here is the point 0, 9. And here is the point 3, 0. And we could just connect the dots. And there is the equation, or sorry, the graph of our line. And so one thing we're going to be interested in is how steep our line is. That's called the slope. All right, so if a non-vertical line passes through the points x1, y1. So this is just a point, all right? x1 is going to represent some value, y1 is just some other value, all right? I know it's a little intimidating with the subscripts, but these are just going to be numbers. And x2, y2. Its slope, which we denote by m, is found by m equals y2 minus y1 over x2 minus x1. It's the y component of the second point minus the y component of the first point over the x component of the second point minus the x component of the first point. This is also the change in y over the change in x, or rise over run. It tells us how much y increases if x increases by 1. Okay, if the line is vertical, right? If the line is vertical, all the x values are the same. This denominator would be 0, and you can't divide by 0. So if the line is vertical, the slope is undefined. All right, so let's take a look at an example. So find the slope of the line that passes through the points -2, 1, and 4, 3. All right, so try this on your own. Pause the video, and then once you give it your best effort, you can unpause and watch me solve it. All right, but this is very straightforward. We have our formula for the slope here, so let's use it. Our slope is the change in y. So 3 minus 1 over the change in x, which is 4 minus negative 2. 3 minus 1 is 2. 4 minus negative 2 is 6. And so the slope is 2/6 or 1/3. All right, so this is literally just using the formula. So what I want to do now is I'm going to draw a couple of lines. And just from looking at the line, we're going to be able to determine some properties of the slope. All right, so suppose this is our line, or this is our line. So in this first graph, as x increases, y also increases. That means our slope is positive. In this next graph, as x increases, y decreases. So here we have a negative slope. In this graph, as x increases, y stays the same, right? It doesn't go up, it doesn't go down. It stays the same. So if we look at our formula for the slope, these two numbers are going to be equal. Maybe they're both 3. Our numerator would be 3 minus 3, which is 0. 0 over anything is 0. The slope is 0 if you have a horizontal line. And what about this last example? Here, our line is vertical. All of our x values stay the same. So our denominator is going to be 0. You can't divide by 0. So this is an undefined slope. All right, so just from looking at the graph, you could get a sense of whether the slope is positive or negative, or 0 or undefined. We're going to be interested in finding when two lines intersect. The point where two lines intersect is going to have a lot of applications. But it's possible, if two lines have the same slope, that they never intersect. And so in that case, we call those lines parallel. So two distinct non-vertical lines are called parallel if their slopes are equal. All right, so parallel lines have the same slope. And no matter how far you check, they're never going to intersect each other. A line L1 with slope m is called perpendicular to the line L2 if the slope of L2 is negative 1 over m. Okay, perpendicular means that the lines intersect at a right angle. And so, for example, if the slope of L1 is 2/3, and the slope of L2 is negative 3 over 2, the lines are perpendicular. Right, why is that? Well, 1 over m, 1 over a fraction is the same thing as just the reciprocal of the fraction. So you take the fraction, look at its reciprocal, and turn it negative. These graphs will meet at a right angle. So it's often the case, and we're going to see this a lot, that you're not given 2 points. It's often the case that you're given a point and the slope of the line. And if we have those 2 bits of information, we could write the equation of the line in a form that's known as point-slope form, right? Because you have a point and you have a slope. So this form is called point-slope. So the equation of a line passing through the point x1, y1 and with slope m, so we have a point, we have a slope, can be written in point-slope form. All right, what is point-slope form? It says y minus y1. So y1 is just going to be a number. So y minus some number is equal to our slope times x minus x1. So if we have a point and a slope, might as well use point-slope form. It comes immediately from those 2 bits of information. Okay, so let's take a look at an example. Let's write an equation for each line that passes through the point 1, negative 2, and has, all right, we're going to have 3 different lines here. So first, slope of 2/3. Second, so these are going to be different lines for each one. Undefined slope. And then finally, the point 2, 3 is also on the line. Okay, so pause the video and try these. You're going to learn much better if you try the problems on your own and see what errors you make. Because if you just watch me, I mean, you're going to see how to do it, but it's not going to stick as well. Okay, so let's start with A. We have a point and we have a slope. So what are we going to use? We're going to use point-slope form. All right, so that's y minus the y component of our point. So y minus negative 2 is equal to our slope, x minus the x component of our point. It's as simple as that. Let's clean this up a bit because it's minus minus. So y plus 2 equals 2/3 x minus 1. Point slope form, if you have a point and a slope, it's so easy. Okay, let's look at B. Undefined slope. Remember, undefined slope means vertical. All of the x values are the same. And so it's x equals the x component of our point. Okay, so our point is 1, negative 2. The x component is 1. So it's x equals 1. And now finally, we have a second point on our line. So let's find the slope of the line, and then we could use point slope again. All right, so how do we get the slope? It's the change in y. So 3 minus negative 2 over the change in x. 3 minus negative 2 is 5. And 2 minus 1 is 1. All right, so the slope of our line is 5, and it contains both of these points. To use point slope, we only need one of the points. I'm going to use the second one, because why not? It doesn't matter. All right, so we're going to have y minus 3 equals 5 x minus 2. Now, if you use the first point, your equation is going to look different. But if you go and plot the two lines, they're actually exactly the same. You know, you just do a little bit of algebra to get from one to the other. Okay, so point slope form is great. It's one of my favorite ways to write an equation of a line. There are times, though, where there's other ways to write the line, which is a little bit more, or just easier based on the information that's given. So another way to write the line is what's called slope-intercept form. So the slope-intercept form of the equation of a line with slope m and y-intercept zero b is y equals mx plus b. Okay, so if you know the slope and you know the y-intercept, you could just write the equation of the line like this, y equals mx plus b. Now, if you have the equation of the line like this, the number next to x is the slope. And then the other term is our y-intercept. So it goes both ways. If we have this equation, we know the slope and we know the y-intercept. Okay, let's do a word problem just to put all these concepts together. And then we'll kind of summarize at the end. So the number of banks in the US is modeled by y equals negative 380x plus 18,483, where x is the number of years since 1980. All right, so we have this, we collected some data and we plotted a line that matched the data. and we got this equation. So 3 parts here. Let's find the slope and y-intercept. Okay, we want to interpret the y-intercept. And then interpret the slope. Okay, so part A is pretty straightforward, but if you don't know how to interpret these values, then, what's the point of using them? So B and C are really the big ones. So A, find the slope and the y-intercept. The equation is written in slope-intercept form, so we just have to read them off. The slope is negative 380, and the y-intercept is the point 0, comma, 18, 483. So how do we interpret the y-intercept? It says when x is 0, y is 18,483. X is 0 is the year 1980. So in 1980, and y is the number of banks. There were 18,483 banks in the US. Okay, what is the slope? How do we interpret the slope? Well, what we should do is figure out what the units for the slope are. It's the y units, which is banks, divided by the x units, which is years. Okay, so the slope is really negative 380 banks per year. This says the number of banks in the US is decreasing. Right? Why is it decreasing? It's a negative slope, so it's going down at a rate of 380 banks per year. Okay? Big takeaway. A slope is a rate of change. So a slope is a rate of change. The number of banks is decreasing at a rate of 380 banks per year. Okay, let's just kind of give a quick recap of what we did today. So, point slope form, y minus y1 equals our slope, x minus x1. Right, so we use point slope form when we have a point and a slope. That's, in my opinion, this is the most useful version of how to write a line. It's very common that we'll have a slope, and it's very common that we'll have a point. So this is a good one to know. Slope-intercept. It's right over there, but we'll write it again. Y equals mx plus b. So if we know the slope and we know the intercept, this is the best form. Or other way around is if this is how the equation of the line is written, we know whatever's next to x is our slope, and the other term is our y-intercept. All right, if we have a vertical line, so if it's straight up and down, the equation of a vertical line is going to be x equals just whatever the number is from the point on the line, the x number. So x equals a, let's say. And then a horizontal line it's y equals. So for a horizontal line, our slope is 0. So this term here would go to 0. We're just left with b. Okay? So I hope you enjoyed today's lesson, and yeah, let me know in the comments if you have any questions or if you have any thoughts about how the course is going so far. All right, see you later.